So in this video, we'll start with the miscellaneous exercise for chapter 7. That's nothing but integration. Okay, so here under this, we'll start with the miscellaneous exercise. Okay, so the first question, it's integration of 1 by x minus x cube dx. So 1 by x minus x cube of dx. Seeing this, of course, you will have to just go by step which method is applicable in this case. Of course, substitution is ruled out actually here. So here we'll see by the method of partial fractions whether you can integrate it. So here I write this integrand as 1 by x minus x cube, which is equal to 1 by x into 1 minus x squared. Now here if you see, I can write it as a squared minus b squared. What is it? It's nothing but a plus b into a minus b. So you have it as x into 1 plus x into 1 by 1 minus x. So I can split this by the partial fractions method here. So when I split it, what will I get? 1 by x into 1 plus x into 1 minus x is equal to a by x plus b by 1 plus x plus c by 1 minus x. This is what you have here. Okay. So I'll have to find out the values of a, b and c. So under that exercise itself, I've told you how to find out the values of a, b and c here. So put the roots in this case. So you have 1 equal to a into, here in this case when you take the LCM, it's a into 1 plus x into 1 minus x plus b into x into 1 minus x plus c into x into 1 plus x. This is what you have here. Now put x is equal to 1. So when you put x is equal to 1, you will have it as 1 equal to. So here when I put x is equal to 1, this becomes 0. This also becomes 0. You are left with c into 1 plus 1. That's nothing but 2. So here you will get c equal to 1 by 2. Next is what? Put x is equal to minus 1. When you put x is equal to minus 1, you will get it as 1 equal to. This becomes 0. Here if you see, you will have it as minus 1 into. Here in this case, 1 minus of minus 1 will give you what? 1 plus 1. That's nothing but 2. So you will have it as b equal to minus 1 by 2. Now put x is equal to 0. What will I get? 1 is equal to a into 1 plus 0 into 1 minus 0. So what is that you get here? It's nothing but a. So what's the value of a equal to here? A is equal to 1. So when I substitute it in this integrand, what is that you have there? Your I is equal to, so what is your I equal to here? I is equal to integral of 1 by x dx plus, what is the value of b here? B is equal to minus 1 by 2, 1 plus x plus c. What's the value of c here? It's nothing but 1 by 2 by 1 minus x dx. Now this is equal to integral of 1 by x dx. Here again it's minus 1 by 2 integral of 1 by 1 plus x dx plus 1 by 2 into integral of 1 by 1 minus x dx. Now we integrate this one. What is integral of 1 by x? It's nothing but log x minus 1 by 2 into integral of 1 by 1 plus x is what? Log of 1 plus x plus 1 by 2 into integral of 1 by 1 minus x is what? Log of 1 minus x divided by the coefficient of x. What's the coefficient of x you have here? It's nothing but minus 1 plus a constant. Okay. Now here it's log x. I can take minus 1 by 2 outside. When I take minus 1 by 2 outside, you're left with, left in this case with log of 1 plus x. So you have taken this minus sign outside, so it becomes plus log of 1 minus x. This is what you have here. So log m plus log n is equal to log of m into n. So I can write this as minus 1 by 2 into log of 1 plus x into 1 minus x plus a constant. So here in this case, I just multiply and divide it by 2 so that I can combine everything and write here. So when I combine it, what will I get here? This becomes, this goes. So it's 1 by 2 into log of x squared minus log of 1 minus x squared. So I can just take this 1 by 2 outside and write it as log of x squared by 1 minus x squared. What's the formula here? The logarithmic rule. Log of m by n is equal to log m minus log n. So here this is using this rule. I'll just split and write it. Okay. Now here we'll go over to the second question here. So what's the second question you get? I is equal to integral of 1 by root of x plus a plus root of x plus b dx you get. So here I is equal to integral of 1 by root of x plus a plus x plus b. Again you have 1 by actually here. So if you have it as 1 by, there are so many ways of doing it. Like the previous one we saw, it was what actually you're doing it by partial fractions. If it's a quadratic form, again see if you can factorize it. If you cannot factorize it, you can do it by the complete form. But here it's not like that. You have it as root of x plus a plus root of x plus b. So we'll see how we can eliminate this root. For that, what I'm going to do here is multiply and divide by the conjugate of the denominator. So you have it as 1 by root of x plus a plus root of x plus b into root of x plus a minus root of x plus b divided by root of x plus a minus root of x plus b dx. So when I multiply this, you will have it as root of x plus a minus root of x plus b divided by, it is a plus b into a minus b. What is it equal to here? A squared minus b squared. So how is that I can write here? Root of x plus a the whole squared you will get here minus root of x plus b the whole squared. So what is this root of x plus a the whole squared? It's nothing but x plus a minus of x plus b. This is what you have here. So x and this minus x, it gets cancelled. So you are left with root of x plus a minus root of x plus b divided by a minus b. Now here it's easy for me to integrate this one. I can just take 1 by a minus b outside. You are left with x plus a the whole power half minus x plus b the whole power half dx. Okay, so what's a formula I'll be applying here? It's nothing but x power n dx is equal to x power n plus 1 divided by n plus 1. So how is it I can write here? 1 by a minus b into x plus a the whole power 3 by 2 is what you have here divided by 3 by 2, because half plus 1 will give you nothing but 3 by 2 minus x plus b the whole power 3 by 2 divided by 3 by 2 plus a constant. Now here if you see, you've got 3 by 2, 3 by 2. Taking it to the numerator, it becomes 2 by 3. So I've just taken it outside here. 2 by 3 into a minus b into x plus a the whole power 3 by 2 minus of x plus b the whole power 3 by 2 plus a constant. Okay. Now the third question. I is equal to integral of 1 by x into square root of ax minus x squared. So again you see here in this case how we can integrate it actually here. So keeping it as it is, I cannot integrate it. So we'll see how we can integrate it. I've written the question again here. It's integral of 1 by x into square root of ax minus x squared. Now here if you see, I can just take this x squared, because if I take x also, you will only have it as root x. It's of not much use here. So I'll just take x squared here. So when I take x squared, root of x squared is nothing but x. So x into x will give you what? X squared into square root of. Here what will you get here? Actually you have it like this. It's 1 by x. You have taken root of x square, that's nothing but x there, into square root of. When I take that out, you will have it as a by x minus 1. This is what you get here, because you have it as ax by x squared. It gets cancelled, so you are left with a by x minus 1. So what is that you have? 1 by x squared into square root of a by x minus 1. Now we will see how we can integrate it here. I'll have to use the substitution here. So t is equal to a by x. Your dt by dx is equal to minus a by x squared, because what is your d by dx of 1 by x here? It is nothing but equal to minus 1 divided by x squared. So you have it as minus a by x squared. So what is your dx equal to here? Dx is equal to, this gets cross multiplied here. It's minus x squared dt divided by a. So you have it as 1 by x squared into square root of, after substitution it becomes t minus 1 into, you have it as minus x squared dt by a. Your x squared and this minus x squared gets cancelled. So you are left with minus 1 by a integral of dt divided by root of t minus 1. Now how will I integrate this one? It's minus 1 by a integral of, when this goes to the numerator, I can write it as t power minus 1 the whole power minus 1 by 2. So again, what's the formula you have here? Integral of x power n dx is equal to x power n plus 1 divided by n plus 1. So how do I write here? T minus 1 the whole power minus 1 by 2 plus 1 is what? 1 by 2 divided by 1 by 2 plus a constant. So here in this case it goes to the numerator. It's minus 2 by a. What's the value of t here? It's a by x minus 1 the whole power 1 by 2 plus a constant. So you have it as minus 2 by a. When I cross multiply, it's a minus x by x the whole power 1 by 2 plus a constant. So it's minus 2 by a into square root of a minus x by a plus a constant. Got it? Yes. Now the fourth question. It's integral of 1 by x squared into x power 4 plus 1 the whole power 3 by 4 dx. Okay. So here again, when you see it itself, you will know it's by the substitution method only. But before going on to the substitution method, we'll see how we can do it here. I'll just take x power 4 here outside. So when I take x power 4 outside, I'll be taking it as x power 4 the whole power 3 by 4. So it gets cancelled. So when it goes outside the bracket, what will happen? You will only get it as x cube. Okay, into 1 plus 1 by x power 4 the whole power 3 by 4. This is what you have here. Okay, so you are left with 1 by x power 5 into 1 plus 1 by x power 4 the whole power 3 by 4. Now what is the substitution I will be using here? Not x power 5. Of course, when you differentiate x power 5, you will get it as 5x power 4, but I have it as 1 by x power 4. So that is not possible. So what's the substitution I put here? Put t is equal to 1 plus 1 by x power 4, because when you differentiate 1 by x power 4, how will you differentiate 1 by x power 4 actually here? When you take that up, you will have it as x power minus 4. What is differentiation of this? Minus 4 x power minus 5. So what will I get? It's minus 4 by x power 5 you will have here. So here if you see, you get it. So it's easy for me to cancel it also here. You understood? So I've written it as 1 plus x power minus 4. What is your dt by dx equal to here? It's minus 4 x power minus 5. So here again, when you simplify it, you will have it as dx is equal to minus x power 5 by 4 dt. Substituted. Your I is equal to integral of 1 by x power 5. It's t power 3 by 4 into what is your dx equal to minus x power 5 divided by 4. So your x power 5 and x power 5 gets cancelled. You're left with minus 1 by 4 into integral of t power. This goes to the numerator. So it's t power minus 3 by 4 dt. So what is the formula you get here to integrate it? It's nothing but t power minus 3 by 4 plus 1. What will you get? It will be nothing but t power 1 by 4 divided by 1 by 4 plus a constant. So of course it gets cancelled. Minus of, substitute the value of t. What's the value of t here? 1 plus 1 by x power 4, the whole power 1 by 4 plus a constant. This is the answer. Okay. The fifth question, I is equal to integral of 1 by x power 1 by 2 plus x power 1 by 3. So it's a slightly different one from whatever we have done so far actually here. You have it as x power 1 by 2 plus 1 by 3. What I'm going to take here is the substitution. Will take it as t power 6. So you may ask me, how is it you get it as t power 6? When you take the LCM of 2 and 3, what will I get here? It's nothing but equal to 6. Okay, so here this is what you have here. The LCM is equal to 6. So I'm going to take that only here, because when I substitute x is equal to t power 6, when I take the LCM, it gets cancelled very easily here. So x is equal to t power 6. What is your dx by dt here? You will get it as 6 t power 5 dt you have here. So yeah, I is equal to 1 by, it is t power 6 the whole power 1 by 2 plus t power 6 the whole power 1 by 3. Your dx is nothing but 6 t power 5 dt. It is 1 divided by, here again it gets cancelled. Here again it gets cancelled. You are left with 1 by t cube plus t squared into 6 t power 5 dt. So take 6 outside. It's into t power 5 divided by t squared can be taken outside. It's into t plus 1. So what happens here actually here? It gets cancelled. So you are left with t cube by t plus 1. Again I have a problem of integration. So you will see, always when I get something in the numerator like this and denominator like this, what will I do here? I can just add and subtract somehow or the other, try to bring it to the denominator. So here what is I do here? I add and subtract here. So you will have it as plus 1 and minus 1 divided by t plus 1 dt you get here. Now here in this case it's a cube plus b cube. So it is t cube plus 1 divided by t plus 1 minus 6 into 1 by t plus 1. Now looking at the first integrand, what is your a cube plus b cube equal to actually here? It is equal to a plus b into a square minus ab plus b square. This is the thing you have here. So how do I write it here? I can write it as t plus 1 into, it is t squared minus t into 1. So t plus 1 divided by t plus 1. So here if you see it gets cancelled. What is this one here? Minus 6 into integral of 1 by t plus 1 is nothing but log of mod t plus 1. Now it's easy for me to integrate it. So it is 6 into integral of t squared is for t cube by 3 minus t squared by 2 plus t minus log of mod t plus 1 plus a constant. I have taken this 6 outside here common. Now substitute the value of x t here. What is your t equal to actually here? Okay, your x is equal to t power 6. This is how you substituted. So here to find out t, I'll have to take the 6th root. That's nothing but x power 1 by 6. So you have it as 6 into x power 1 by 6 the whole power 3 divided by 3 minus x power 1 by 6 the whole square divided by 2 plus x power 1 by 6 minus log of mod x power 1 by 6 plus 1 plus a constant. So what happens here actually? Here it gets cancelled. Here also it gets cancelled. So you're left with 6 into x power 1 by 2 by 3 minus 6 power 1 by 3 divided by 2 plus x power 1 by 6 minus log mod of x power 1 by 6 plus 1 plus a constant. The sixth question, I is equal to integral of 5x divided by x plus 1 into x squared plus 9 dx. So how will you do it actually here? It's clearly only by the method of partial fractions. You have a linear one into a quadratic one here. So what is the method you have under partial fractions here? We'll write it as a by x plus 1 plus bx plus c divided by x squared plus 9. So I'll have to find out the values of a, b and c. So here when I cross multiply and take the LCM, what is that you get? 5x is equal to a into x squared plus 9 plus bx plus c into, what will I get here actually? Here it's nothing but equal to x plus 1. This is what you have here. When I cross multiply, you will have it as bx into x plus 1. Now put x is equal to minus 1. So when you put x is equal to minus 1, what will happen? Minus 5 is equal to a into minus 1, the whole square is nothing but 1 plus 9 you get here. So minus 5 is equal to 10a. So what's the value of a you get here? It is equal to minus 1 by 2. Now equate the coefficient of x squared and x to find out the values of b and c. So what is your x squared here in the left hand side? Nothing. 0 equal to, what is the coefficient of x squared? It's nothing but a plus, when you multiply this, you will have it as bx squared is what you get here. So what's the coefficient of x squared? It's nothing but plus b. So 0 is equal to a plus b. 0 is equal to minus 1 by 2 plus b. So what's the value of b equal to here? 1 by 2. Now equate the coefficient of x. What's the coefficient of x in the left hand side here? 5 equal to, here if you see you don't have any x term, but here you have it as cx, and here this bx into 1, when you multiply you will have it as bx. So what are the coefficients you have here? It's nothing but b plus c. You know what's the value of b? It's nothing but 1 by 2. So 5 is equal to 1 by 2 plus a constant. So what is c equal to here? 5 minus 1 by 2. So what's the answer you get here? It is equal to 9 by 2. So here your I is equal to integral of, substituting it, it's minus 1 by 2 divided by x plus 1 plus 1 by 2x plus 9 by 2 divided by x squared plus 9 dx you get here, which is equal to minus 1 by 2 into integral of 1 by x plus 1 plus, here again if you see you can just split it, 1 by 2 into integral of x by x squared plus 1 dx, plus here again it's 9 by 2 into integral of 1 by x squared plus 9 dx. This is what you have here. Okay, so here when I integrate it, it's minus 1 by 2 log of mod x plus 1 you have. Now how can I integrate it? Only by the method of substitution here. So when I substituted t is equal to x squared plus 9, your dt by dx is equal to 2x, and you will get dx is equal to dt divided by 2x you get. So substitute it, 1 by 2 into integral of x by t into dt divided by 2x, your x and x gets cancelled. It's plus 9 by 2 into, it's nothing but 1 by a. Okay, because what is integral of dx divided by x squared plus a squared? What's the formula you have here? Actually it's nothing but 1 by a into tan inverse of x by a. This is what you get here. So it's 1 by a means what will, you already have this 9 by 2. I've written that 9 by 2. A is what actually? It's nothing but 3 squared. So your a will be equal to 3. So it's 1 by 3 tan inverse of x by 3 plus a constant. So here again it's minus 1 by 2 log of mod x plus 1 plus 1 by 4 into integral of dt by 2. Here of course it gets cancelled. You're left with 3 by 2 tan inverse of x by 3 plus a constant. So it's minus 1 by 2 log of mod x plus 1 plus 1 by 4 into log of mod t plus 3 by 2 into tan inverse of x by 3 plus a constant. So what's the last step you have here? It's minus 1 by 2 into log of mod x plus 1 plus 1 by 4 into log of, what will I get here? Mod of x squared plus 9 you get here. Plus, what is the next one you get here? It's 3 by 2 into tan inverse of x by 3 plus a constant. This is the answer you have here. Okay. The seventh question, it's integral of x sin x by sin of x minus a. Okay, so integral of sin x by sin of x minus a. Again, it's another new form only you have here. So far we have not done such questions here. So you have it as sin of x minus a. So we'll try to bring this numerator also as the denominator. So what can I do here? Actually here I can subtract and add here a here. So that is what I have done. Your I is equal to integral of sin of x minus a plus a. So what's a formula I can apply here and split it actually here? It's nothing but sin of a plus b. What is your sin of a plus b equal to here? It is sin a cos b plus what will I get here? It's nothing but cos A sin B. This is what you have here. So it is sin A cos B, means this is your A and this is your B. So how do I write? It's integral of sin of x minus A into cos A you get here, plus cos of x minus A into sin A divided by sin of x minus A dx. Okay, so here your A is nothing but x minus A and your B is nothing but equal to small a. So I've used sin A cos B plus cos A sin B. Now we'll just split it as two separate integrands here. So when I split it, what will I get? It's equal to integral of sin of x minus A into cos A divided by sin of x minus A, plus here when you write it, it's cos of x minus A into sin A divided by sin of x minus A dx. Now you can write here, this gets cancelled. It's integral of cos A dx. Here cos by sin can be written as cot of x minus A into sin A. So here when I take this cos A outside, you will have it as integral of dx. But I take this sin A. Why is it I am taking cos A and sin A outside the integral? Because they are only constant. Because you don't have it as cos x, it's only cos A. Cos A is nothing but a constant. You understood? Plus sin A into integral of cot of x minus A. So this is another thing you will have to remember, integral of cot x dx. What is integral of cot x dx? Actually it is equal to log of mod sin x. Okay, so here what is integral of tan x? Actually here integral of tan x is equal to minus log mod of cos x. These two are new formulas. Actually here I have not given you under the formula list also, I have not mentioned it. Actually you do it by the method of substitution and get it. Okay, so here it's cos A. What is integral of dx? It's nothing but x. So I'll write it as x cos A plus sin A into, what will I get here? Actually here it's nothing but log into mod sin of x minus A. Okay, so here you have it as log of mod sin of x minus A plus a constant. This is what you have here, log mod of sin of x minus A plus a constant. Is it clear? Yes. Now here we'll go over to the 8th question. So before going on to the 8th question, we'll just recall a property under this one here. Your e power log x to the base e. How do I write it here? It's nothing but equal to x. So I'll be making use of this property twice under this miscellaneous exercise. One under the 8th question and later on I'll tell you the question where we do that. Here if you say it's integral of e power 5 log x minus e power 4 log x by e power 3 log x minus e power 2 log x. So looking at it, you may think that it's a complicated one, but it's a very easy one here. Here first of all, this exponential part, that is a power part, whatever you've got, I can write my log of m power n. How do I write it here? I can write it as n into log m. So using that I write this as e power log x power 5 you have here minus e power log x power 4 divided by e power log x cube. Okay, log x cube minus e power log x squared you get. So as I told you, your e power log x is nothing but equal to x. So here I can write it as x power 5 minus x power 4 divided by x cube minus x squared dx. So here this is equal to integral of x power 4 can be taken common. So it is x power 4 into x minus 1 divided by x squared into x minus 1 dx. So what happens here? It gets cancelled. Here also if you say it gets cancelled, you are left only with integral of x squared dx. What is integral of x squared dx here? It's nothing but x cube by 3 plus a constant, because integral of x squared will give you what? X cube by 3. The 9th question, integral of cos x by root of 4 minus sin squared x. Yes, so you have one look at it, you will be able to know what type it is actually here. What is it actually here? It's nothing but your substitution method, because very simple, what is your differentiation of sin x? That will give you nothing but cos x. So it's easy for me to do the substitution here. I is equal to integral of cos x by root of 4 minus sin squared x dx you get here. So what will you do? Put t is equal to sin x. Your dt by dx is nothing but equal to cos x you have here. Okay, so your dx is equal to dt by cos x. So what is your I equal to? Integral of cos x by root of 4 minus t squared into dt by cos x you get. Your cos and cos gets cancelled, which is equal to integral of dt by root of 4 minus t squared. So what is the formula you have here? Integral of dx divided by square root of a squared minus x squared. What's the formula you get here? It's nothing but sine inverse of x by a. This is the formula you have here. Okay, because it's a squared minus x squared and not x squared. So what is your a squared here? It's 2 squared minus t squared. So how do I write it here? This is equal to sine inverse of the upper limit is what? T, not the upper limit, sorry. Instead of x, you have it as t. So you have it as sine inverse of t by 2 plus a constant. Now you will have to substitute the value of t. What's the value of t you get here? It's nothing but equal to sine x you get here. So here when I substitute it, what will I get here? It's nothing but sine inverse of sine x by 2 plus a constant. This is a substitution you have here. Put t is equal to sine x you get. So it is sine inverse of sine x by 2 plus a constant. Is it clear? So this one is a very easy and a direct question also. Okay. Now coming over to the 10th one. So the 10th one, it's integral of sine power 8x minus cos power 8x divided by 1 minus 2 sine squared x cos squared x. So unlike the previous one where you saw it was possible by substitution, here it's not possible. So we'll see how we can simplify it first and then we can do it. There are so many ways for us to simplify it, especially the numerator. See, the sine power 8 I have written it as sine power 4x the whole squared minus cos power 4x the whole square divided by 1 minus 2 sine squared x cos squared x. So here if you see, you have it as a squared minus b squared. It's nothing but equal to a plus b into a minus b. So what is your a here? Sine power 4x plus cos power 4x into sine power 4x minus cos power 4x divided by, of course the denominator is the same, 1 minus 2 sine squared x cos squared x. Now here this one I keep it as it is. Here again I can apply a squared minus b squared, because how can I write this as? Actually I can write it as sine squared the whole squared minus cos squared the whole squared I can write. So again it will be what? Your a will be what? Sine squared x plus cos squared x into sine squared x minus cos squared x. What is the sine squared x plus cos squared x? It's nothing but equal to 1. So this goes off actually here. So you're left only with, in this case, sine power 4x plus cos power 4x into sine squared x minus cos squared x. So I have just rewritten it as sine squared x minus cos squared x. Now coming to this, I have written it as sine squared x the whole square plus cos squared x the whole square divided by 1 minus 2 sine squared x cos squared x. Now why I have written it like this? Okay, you know, you would have studied in your lower classes what is a squared plus b squared equal to. What is it equal to here? It's nothing but a plus b the whole squared minus 2ab. Now here whatever I round it, I can write this as, I can write it as sine squared x plus cos squared x the whole squared minus 2 into sine squared x into cos squared x. Can I write it like this using this identity? Only this part. Actually this one will be as it is. Okay. So we have it as integral of sine squared x minus cos squared x. As I told you earlier, I have written the other one here. It's 1 minus 2 sine squared x into cos squared x. Now what is this equal to here? It's nothing but 1 squared. So I can, now here, what is the sine squared x minus cos squared x actually here? You would have known this. Your cos squared x minus sine squared x is nothing but equal to cos 2 x. But here you have it as sine squared x minus cos squared x. Therefore I write it as minus cos 2x. Into, you are left with 1 minus 2 sine squared x by 1 minus 2 sine squared x. It gets cancelled. So here it is equal to integral of minus cos 2x. When I integrate it, you will have it as minus sine 2x divided by 2 plus a constant. This is what you have here. Okay. So here the simplification process only is little lengthy under the 10th question, but otherwise integration, if you see here, it's very easy. Okay. Now coming over to the 11th one, it's integral of 1 by cos of x plus a into cos of x plus b dx. So whenever you have something like this in the numerator, cos of x plus a and cos of x plus b, the same thing I must somehow or the other bring it to the numerator also. So I see how I can bring it to the numerator here. Slowly I can introduce only a constant term. I cannot multiply and divide by the variable. I cannot multiply and divide by cos of x plus a or cos of x plus b or anything like that. So I just take a constant first. I can add or subtract within the integrand. Multiplication and division only with a constant is applicable. So I just multiply and divide by 1 by sine of a minus b into integral of sine of a minus b by cos of x plus a into cos of x plus b dx. So here this is equal to 1 by sine of a minus b into integral of, here I have just added and subtracted x here. So it is x plus a minus x minus b divided by cos of x plus a into cos of x plus b. Now I have just split it as two separate parts here. It's 1 by sine of a minus b. Here if you see, it's integral of sine of x plus a minus of x plus b you've got here. So what formula it is actually here? Sine of a minus b. So what is your sine of a minus b equal to here? It's nothing but sine a cos b minus cos a sine b. This is the formula you have here. Okay. So here using this I can write it as 1 by sine of a minus b integral of sine of x plus a into cos of x plus b minus cos of x plus a into sine of x plus b divided by, of course you will have this dx here, the denominator cos of x plus a into cos of x plus b. Now we'll just separate it as two separate integrands. 1 by sine of a minus b, you can write it as sine of x plus a into cos of x plus b divided by cos of x plus a into cos of x plus b dx minus integral of cos of x plus a into sine of x plus b divided by cos of x plus a into cos of x plus b dx. So of course this gets cancelled. Here again if you see it gets cancelled here. So you're left with what? 1 by sine of a minus b into integral of tan of x plus a dx minus tan of x plus b dx. So already I mentioned the formula. What's the formula you get here? 1 by sine of a minus b you get here. What is this equal to here? It's nothing but log of minus log of mod cos of x plus a is what you get here. Here again you will have minus. So I'll just write it as plus log, because minus log cos you will get here. Minus into minus is nothing but plus cos of x plus b, mod cos of x plus b plus a constant. So by using the logarithmic rule I can write it as 1 by, how do I write here? Sine of a minus b. It is nothing but log of mod, what will I get? Cos of x plus b divided by cos of x plus a plus a constant. This is what you have here. Okay, so yeah, plus a constant. You understand? So if at all you get integrands of this type, actually here the simple thing here, okay, you will have to multiply and divide in this case. Actually here, multiply and divide first of all by a constant. Here in this case I have taken it as sine of a minus b. Okay, you may think why is it I cannot take it as cos of a minus b? If I take it as cos of a minus b, then to integrate it, so to, what is it here, to cancel it and then to integrate it, it will be a little tedious one, and that is why we do it by this method here. Okay. The 12th question here, it is integral of x cube divided by 1 minus x power 8 dx. So before going on to the solution here, is x cube by square root of 1 minus x power 8. For sure it's going to be substitution, but I'll just write this as x cube divided by square root of 1 minus x power 4 the whole square dx. Now it will be more clear why I say that it is by the substitution. So we write it as x cube by root of 1 minus x power 4 the whole square dx. So I can make this, when I differentiate x power 4, what will you get? It's 4x cube actually here. Okay, so that's the reason I told you for sure it's going to be by the substitution method, because when you see it you may think when I differentiate x power 8 you will only get it as 8x power 7, because that's of no use here. But I'll have to just simplify it a little like this and write so that it's easy for me to do the substitution method. So here that's what you have. So put t is equal to x power 4. Your dt by dx is equal to 4x cube. What is your dx equal to? Your dt by 4x cube. So your I is equal to integral of x cube divided by square root of 1 minus t squared into dt divided by 4x cube. So you have it as integral of dt by square root of 1 minus t squared. What's the formula again you will have here? Integral of dx divided by square root of a squared minus x squared. What's the formula here? It's equal to sine inverse of x by a. So what is that you get here? It's 1 by 4 into integral of sine inverse of t by 1, because your a is nothing but equal to 1 plus a constant. Substitute the value of t. What's the value of t here? It is equal to x power 4. So you get it as 1 by 4 into sine inverse of x power 4 plus a constant. Okay. Now the 13th question, I is equal to integral of e power x by 1 plus e power x into 2 plus e power x dx. Now here you just have a look at it actually here. It's somewhat by the partial fraction method but not directly here. What is the problem I have here? My e power x. Okay, so we'll just by substitution we'll eliminate that e power x and then do it by the partial fraction method. So you get it as t equal to e power x. Your dt by dx is equal to e power x you get here. Your dx is equal to dt divided by e power x. So what is your I equal to? Integral of e power x divided by 1 plus t into 2 plus t into dt divided by e power x. Your e power x and e power x gets cancelled, which is equal to integral of dt by 1 plus t into 2 plus t. So here you will have to just split it by partial fractions. 1 by t plus 1 into t plus 2 is equal to a by t plus 1 plus b by t plus 2. You understood? See how I have converted this e power x in terms of an algebraic one, and then again I will have to substitute it. Okay. You have it as 1 equal to a into t plus 2 plus b into t plus 1. So t is equal to minus 2. You will get 1 is equal to minus 2 plus 1. That's nothing but minus 1. So your b is equal to minus 1. Now put t is equal to minus 1 here. You will get 1 is equal to a into minus 1 plus 2. That's nothing but equal to 1. So your I is equal to integral of a is equal to 1 by t plus 1 minus 1 by t plus 2 dt. So what will I have? It's log of mod t plus 1 minus log of mod t plus 2 plus a constant. So what's the formula you get here? Log of a minus b is what? Log of a by b. So I can write it as log mod of t plus 1 by t plus 2 plus a constant. What's the value of t you get here? It's e power x. So log mod of e power x plus 1 divided by e power x plus 2 plus a constant. Is it clear? Okay. Now the 14th question. So here it's I equal to integral of 1 by x squared plus 1 into x squared plus 4 dx. So when you have see it itself, you know that it's nothing but by the partial fractions here. But here if you see, I told you if it's a quadratic, I told you to use ax plus b plus b. Okay, so that's the thing I asked you to use here. But here, since both are of the same degree, okay, both are of the same degree, listen well, both are of the same degree here, that's the reason I just split it as it is here. A by x squared plus 1 plus b by x squared plus 4. Suppose if you had it as 1 as linear and 1 as quadratic, then I'll have to use the method a by plus b bx plus c. Okay, so your 1 is equal to a into x squared plus 4 plus b into x squared plus 1 you get here. So equating the coefficient of x squared and constant, what will I get? Your 0 is equal to, first the x squared, you don't have a x squared term, so it is 0 equal to, here it is nothing but a plus b you have here. So here the next one is what? Constant, 1 is equal to, when you multiply it, it's 4a plus b. Now, just subtract it. 0 minus 1 is nothing but minus 1. A minus 4a is nothing but minus 3a. Of course, it gets cancelled. So, what's the value of a here? 1 by 3. And what's the value of b? B is equal to minus 1 by 3. Got it? So, substitute it. I is equal to integral of 1 by 3 by x squared plus 1 plus minus 1 by 3 by x squared plus 4. So, I'll just take this and separate it as two separate integrands. 1 by 3 into integral of 1 by x squared plus 1 dx minus 1 by 3 into integral of 1 by x squared plus 4 dx you get. So here it's 1 by 3 into tan inverse of x minus 1 by 3 into, what's the formula you get here? Integral of dx divided by x squared plus a squared. So what will I have? It's 1 by a into tan inverse of x by a. This is what you get here. So it's 1 by 2 into tan inverse of x by 2 plus a constant. Okay. So I just take this 1 by 3 outside. You are left with 1 by 3 into tan inverse of x minus 1 by 2 into tan inverse of x by 2 plus a constant. So once again I am telling you here, only if you have it as 1 by both of the same degree you can do it. Even if you have it as x squared by, don't do that. You will have to do it by the substitution method. Such a problem I have done under the partial fractions exercise itself. Okay. So the 15th question, integral of cos cube x into e power log sin x dx. I told you I will be using this property again here, e power log x. What is e power log x equal to? It's nothing but x. Now coming to this e power log sin x, how can I write here? I can just write it as sin x. I is equal to integral of cos cube into sin x dx. Now, yeah. So as I told you earlier actually here, what is that you will do here? You can just do it by the method of substitution. So what's the substitution I put here? Put t is equal to cos x. Your dt by dx is equal to minus sin x, and your dx is equal to, you have it as minus dt by sin x. So when I substitute it, it's t cube into sin x into minus dt by sin x. It gets cancelled. You're left with minus t cube dt. When I integrate it, it's minus t power 4 by 4 plus a constant. So it's minus, what's the value of t here? T is equal to cos. So you can write it as minus cos power 4x divided by 4 plus a constant. Is it clear? Okay.